This video is for lesson 12.5 and it is the final probability lesson in this unit. So let's go ahead and take a look at the vocabulary. I hope you're using a pencil, and also I hope that you're writing in the learning target. I can find the probability of independent and dependent events. So the first two vocabulary have to do with those two words. Two events are independent events if the occurrence of one event does not affect the occurrence of the other event. And then that's the opposite of a dependent event if the occurrence of one event does affect the occurrence of the other. And we're going to go ahead and do some examples, of course, to show the difference between those two types of events. The last vocabulary term here, the probability that event B occurs, given that event A has already occurred, is called a conditional probability. And this is how we write that. The probability of B taking place given that A has already taken place. So that means that there is a dependence on A taking place before B takes place. In example 1, it says identify independent and dependent events. And the situation is that you have a drawer that contains 6 red markers and 4 blue markers. You randomly choose a marker from the drawer and do not replace it. Okay, so if you do not replace it, then the second choice depends on what you draw out the first time. So anytime you do something and do not put that item back, then you are creating a dependent event, because the choice that you draw the second time, or event B, would matter because you did not put it back and the same number of options are not available for that second draw or that second spin or whatever the situation might be. So let's say that you do not replace it and then you randomly choose another marker. Tell whether the events are independent or dependent. Well, I've already answered that. It's dependent because whatever takes place for event A is going to affect how event B takes place. So the first marker that you choose is blue, is event A. Well, what's the probability of drawing blue? A blue marker. Okay, the probability of drawing a blue marker, it tells us right here that there are 4 markers in total. 4 blue markers, that is, and in total there are 10 markers. So for the first draw, it looks like we have a probability of 2/5. When I reduce that fraction, 2 out of 5 of the markers are blue. Now, when we look at event B, it says the second marker you choose is also blue. Well, remember, there are not as many markers in the drawer anymore because you took the blue one out, and remember we said we were not going to replace it. So for the probability of the second event taking place after the first event takes place, remember that's the probability of B taking place after A has already taken place, is going to be the idea that there are only 9 markers left in the drawer. And how many of those markers are blue? Well, we already drew one out, so that means that now there are only 3 blue markers left. And so therefore we could say that the probability of drawing a blue marker the second time is only 1 out of 3, because 3/9 reduces to 1/3. And let's take a look at the first on your own practice problem. It's telling you that you have to decide whether the events are independent or dependent. So let's go ahead and read. It says that a bucket contains 4 tulip bulbs and 3 daffodil bulbs. And bulbs are those things that you plant in the ground, and then, a few months later you end up with some flowers that pop up in the spring. And when we randomly choose a bulb, then we're going to plant it. And then you choose another bulb. So event A is that you choose a bulb and that it is a tulip. So what's the probability that you're going to choose a tulip from this bin, this bucket that you have? Okay, so do that first. And then the second event that you're going to do, or event B, is going to be that you choose a daffodil bulb. Well, what's the probability that you choose a daffodil bulb after you've already chosen a tulip bulb? Remember, you are not going to put the first one back because you are planting it, so that reduces the number of total bulbs you have left. So I'd like you to tell whether this is independent or dependent, and then I'd also like you to find the probability of each of these events, please. And now I'd like to look at example 2. Find the probability of independent events. Independent events do not affect each other. Okay, so this is a situation where, we could do a couple things and neither one of them makes any difference to the other one. So we do need a little formula for this one, so please write this down. Probability of A, the first event, times the probability of B, the second event, which does not have anything to do with the first event, is the probability of A and B taking place. Okay, so when we multiply the probability of A times the probability of B, then we find out the probability of both things happening. And we want to do that now with this problem. So Kanisha and Ramon each have a standard deck of 52 cards. So each of them has their own deck of cards, which makes this an independent event. Each person draws a card at random from his or her deck. Find the probability that Kanisha draws a heart and Ramon draws a 6. Well, let's take a look at the standard deck of playing cards, and then we can come back and look at this problem. Okay, so here we have a picture of all the different cards in a set of 52 cards. And as you see, the two suits that are red are diamonds and hearts, so in case you're not familiar with a deck of cards. And then we have clubs that are black, spades that are black. And as you know, that there's a ace and then a 2 through 10 card, and also a jack, queen, and king for each suit. So there's 52 cards in total, and remember, Kanisha is going to draw a heart. So what's the likelihood that she draws a heart? So if we go back to Kanisha, what's the probability that she draws a heart? All right, well, there's a total of 52 cards, and remember, Kanisha has her own set of cards. And in terms of how many hearts there are all of these hearts. So her possibility is 13 out of 52. All right, and then on the other hand, Ramon has his own deck of cards. And what's the possibility that he draws the number 6? Well, he has 52 cards in his deck. How many of the cards in the deck are 6s? Well, it looks like there are only 4. So he has a less chance of drawing a 6. Let's see, the probability of Ramon drawing a 6 is 5 over 52. Now we can reduce these, but let's go back to our problem, and we're going to take a look at multiplying these two probabilities together so that we can find out the likelihood of both of these things taking place. So the probability of Kanisha drawing a heart was 13 out of 52, and we can reduce that to 1 out of 4. So she has a 1 out of 4 chance of drawing a heart. That was for probability of A, Kanisha drawing a heart. Probability of B is Ramon drawing a 6. That's 4 out of 52 based on what we said on the other screen there. And this is going to reduce down to 1 out of 13 chance of him drawing that particular number. Now, with these two probabilities, to find out the chance of both of them taking place, that's what we mean by probability of A and B, we need to multiply these together. So 1 over 4, that's Kanisha's probability, times 1 over 13, which is Ramon's probability, and we need to multiply them. When you multiply fractions, you just simply multiply across the top and multiply across the bottom. And then you take your calculator out and you divide 1 by 52 and you get 0.019. Now that's the chance that it's going to happen, and if we put that in terms of a percentage, it's a 1.9% chance that Kanisha will pull out a heart and Ramon will pull out a 6. So that means there's less than 2% chance. This is a very slim chance of this taking place, but that's how you're going to find it. You're going to need to know both of the probabilities and then multiply them together. So with the on your own problem, I'd like you to take a look at this here where you have 3 red sweaters, 2 black sweaters, 4 gray sweaters. You randomly pick one sweater. You do put it back. Okay, that means that it's not dependent. You do put that first sweater back and then randomly pick another one. Find the probability that the first sweater chosen is red and the second is gray. All right, so you'll have to think about how many sweaters you have in total, and then find the probability that you will find, or sorry, pull out a red one, and what's the probability that you're going to pull out a gray one. And then once you find those, make sure you multiply them together, and that will give you the probability of this particular thing taking place. Okay, so example 3 says that we want to find a probability of dependent events, and in this case we have a bucket that contains 40 yellow golf balls and 30 white golf balls. Okay, so dependent means that something's going to take place that's going to change the probability of the second thing taking place. Now we still need to use our same formula, probability of A times the probability of B taking place after A has already taken place. Remember, that's the conditional one when we have a dependent situation. That's going to be the probability of A and B, just like we just had with Ramon and Kanisha and the cards. All right, so we need to find the probability that the first ball is white. Okay, so the probability of A taking place is going to be pulling out a white ball, and the second ball is yellow. So the probability of B taking place is going to be that you pull out a yellow one after you've taken the white one out and hit it toward the flag. Okay, so you're not replacing it. You're not putting it back in the bucket because you've hit it. So how many balls in the bucket total? There are 70, so that number is going to go on the bottom. And how many of the balls are white? Well, that's what the chances of you pulling out a white ball and hitting it are going to be 30 out of 70. And the second thing that we want to find out is what's the possibility that you're going to pull out a yellow ball after you've already hit one of the balls out of the bucket. So you have one less ball in the bucket, so now you only have 69 balls in the bucket. And how many of them are yellow? 40 of them are yellow. So following the formula that we have here, the little equation, taking 30 over 70 and multiplying it by 40 over 69, we're going to get the probability of both of these things taking place. So before I go any further, I would like to reduce 30 over 70. That's going to just be 3 over 7. I'm just reducing that. And then I would like to multiply that by 40 over 69. That just makes it easier to work with these numbers. So again, we're just going to multiply across the top. 40 times 3 is 120, and 7 times 69 is 483. So I can just divide these two numbers, take 120, divide by 483, and that's going to give me 0.248. So the chances of me pulling out a white ball, hitting it, and then picking a yellow ball out is going to be 24.8% chance. Almost 25%, only a quarter of the time pretty much would I have that order of pulling out white and then pulling out yellow. On the back of your paper you have an on your own practice problem. In this first practice problem it says that you have a bowl that contains 10 peaches and 8 nectarines. You randomly choose a piece of fruit and then you eat it. Okay, if you eat it, you're not putting it back into the whole amount of fruit that's in the bowl. So there's going to be one less fruit the second time you choose one. And it says to find the probability that the first piece of fruit that you pick is a peach, you eat that fruit, and then the second one is a nectarine. So remember, the first time that you're picking is going to be a peach. Okay, so find the probability that you have for peaches, pulling out a peach, and then find the probability that you pick a nectarine the second time, but it's only because there's one less. Don't forget that you want to change the denominator on that bottom one. Once you find those two probabilities, then you want to multiply them together. And then for example 4, we are going to do, we're going to need to take a look at this table over here. It says that it shows the number of juniors and seniors who have different window treatments in their room. Use the table to estimate A, the probability that a randomly chosen junior has blinds. Okay, so we need to pay attention to juniors that have blinds. And then we also need to find the probability that a randomly chosen student, okay, it doesn't say a specific grade or junior or senior, it just says student who has blinds in his room or her room and is a junior. Okay, so we kind of need to total up the columns here as well as the rows. So if I total up all of the juniors, there are a total of 162 juniors total. And then in terms of the seniors, there are 146 seniors. Now I also would like to know how many students in total have blinds. So I want to add these two together, 41 plus 26. That's going to help me out. And 96 plus 84. Knowing the total of these is going to help in this work that we're doing here. And then there's 61 total with curtains. All right, so let's go back to part A here. The probability that a randomly chosen junior has blinds. So they have to be a junior and they have to have blinds. So let's just go ahead and put in 162 juniors, and 41 of them happen to have blinds. So in terms of, and this was for part A up here, I just didn't have enough room to write it in there. So if I use a decimal form, if I take my calculator out, I get 0.253, so 25.3% chance that a junior that I happen to survey has blinds. All right. Now for part B, this over here, we're going to do the probability that a student has blinds is a junior. So we have to look at the number of students that have blinds. Total is 67. And how many of them happen to be juniors? Well, that looks like there are 41 juniors that have blinds. Now if I use my calculator, I can find out what the percentage is. It's going to be 0.612, and that's 61.2% of people who have blinds happen to be a junior. Now I'd also like you to do the on your own practice using this table still. It's asking you to use the table to find the probability that a randomly chosen student who has curtains is a senior. Okay, so make sure you're looking at the curtains row and pick seniors there. And then for part B, what's the probability that a randomly chosen senior, so you have to look at the seniors, has curtains. Okay, so there's a different probability for those two. And I would like you to cross off the example 5. We're actually not going to do example 5, so go ahead and put an X over that, and then also put an X over the on your own. We're just not going to get into that. We don't have enough time left in this semester to do all of these extra examples. I think you guys have a lot of information now, and this will be our final lesson in probability. Good luck on your own problems, and let me know if you have any questions, please, when you see me in class.